Find the cubic root of z equals minus 4 root 2 plus 4i root 2. So z equals minus 4 root 2 plus 4i root 2. So if you look at that, both the real and the imaginary parts have a common factor of 4 root 2. So I'm going to pull that out. Equals 4 root 2. So that would be minus 1 plus I, which makes things a lot easier. So if we just draw a little diagram to find the argument of this, we'll just use the minus 1 plus I. So the minus 1 is on the real axis, so that can be here. Minus 1, the plus I can be up here. So 1 on the imaginary, so it's over here. Okay, so you can see that angle there is 90 plus 45, which is 135 degrees. Okay, so you know that 180 equals pi, so 90 equals pi over 2. 45 is pi by 4, so if we add, well, we can either multiply the 45 by 3, would get you to 135, or you could add the 90 and the 45, so you can say, well, pi by 2 there is 2 pi by 4, and you can add that to the pi by 4, so 135 is 3 pi by 4 as an argument. For the modulus, so the modulus of z is going to be, well, it's the 4 root 2 that we pulled out, so 4 root 2 times the square root of 1 squared plus 1 squared. 1 squared is 1, the other 1 squared is still 1, 1 plus 1 is 2, so we've got square root of 2 times another square root of 2 is 2, times the 4 is 8, so the modulus of z is 8, so that means that z equals 8 cis 3 pi by 4. Okay, so once we now got this in cis form, we can use De Moivre's theorem, but just before we do that, we need to remember that there's going to be 3 roots, right? The way you get 3 roots are by considering the periodicity of this. So yes, this is 3 pi by 4, but then if I added on another 2 pi, I would get to the same place, and if I added on another 2 pi. So what it actually is, that z equals 8 cis, and it's 3 pi by 4 plus k 2 pi, right? Where k needs to be an integer. Okay, so basically, if you have 8 cis 3 pi by 4, and then if you just increase the argument by 2 pi, by 360 degrees, it gets you back to exactly the same place. We need to do this whenever we are finding an nth roots type problem involving complex numbers, because otherwise you're only going to get one answer. And you look for cubic root, then you're going to want 3 answers. Fourth root, you're going to want 4 answers, and so on. So now we can do the cube root of z, which is z to the power of a third. Well, that equals the cube root of all of this. So 8 cis 3 pi by 4 plus k2 pi. So z to the third equals all of that to the power of a third. Okay. And now we can, obviously we can just do the cube root of 8 for the 8 to a third. So we need to do 8 to a third times cis 3 pi by 4 plus k2 pi to the power of a third. And we do that using De Moivre's theorem. So that equals the cube root of 8. Cube root of 8 times cis. And remember, if you're using De Moivre's theorem, you just multiply the argument by the power. So we're multiplying by a third, it's the same as dividing by 3. So it's 3 pi by 4 divided by 3, so that's pi by 4, plus, and then you've got k 2 pi by 3 plus k2 pi by 3. Okay, so that equals, and I want to be able to add these together, and I'm going to use different values of k so I get these three answers. I'm actually going to draw them on an Argand diagram if I have space. So the cube root of 8 is just 2, so it's 2 cis, and now I'm going to call this pi by 4. We've got a common denominator of 12 for 4 and 3, so that can be 3 pi by 12 plus this, you're going to multiply that by 4, so k8 pi by 12. Okay, so once you've got that, we need three solutions. You use three consecutive integers, and that will get you your three solutions. Now, it's easy just to use. It doesn't matter which three consecutive integers you use, it will always get you to the three answers, and it will always be spaced nicely around the Argand diagram, as we should see later. But you should pick the integers that make your life easy. 0 is always a good choice, and often what people forget that you can use -1, 0 and 1, which is often better than 0, 1 and 2, and definitely better than 1, 2 and 3. Just remember, k needs to be an integer. So we will start with let k equal -1, okay? So that would mean that cube root of z, the first one, so z to the third is going to be 2 cis 3 pi by 12 minus 8 pi by 12. So 3 minus 8 is minus 5 pi by 12. So at this point, you'd probably have a bit of a think about pi by 12 and multiples of it, and just see if you can do it easily, exactly. You know, pi is 180, pi by 3 is 60. If you divide it by 2 again, pi by 6 would be 30. Pi by 12 would be 15. So that you can do it, because you could use a compound angle, because you know about 45 and 30, so you could get to 15 that way. But for this particular question, I'm just going to leave it in this form: 2 cis minus 5 pi by 12, and I'm going to draw it on a diagram. So we're going to call this the first root, so I'm going to call this W1 as in the first root. If we let k equal 0, so z to the 1/3 equals 2 cis, well, it's 3 pi by 12 plus nothing. So remember, 3 pi by 12 was just pi by 4, so 2 cis pi by 4. Okay, and that can be the second root, W2. And if we let k equal 1, z to the power of a third is going to equal 2 cis, well, it's 3 pi by 12 plus 8 pi by 12, so that's 11 pi by 12. And that can be the third root, and because it was a cubic, I now know I'm finished. So I've got my 3 cube roots. I'm going to represent these on an Argand diagram. Okay, so we're just considering the radius of the circle. All the lines are going to have length 2, because all of the complex numbers have a modulus of 2. I'm just going to find these angles. So for the first one, it was minus 5 pi by 12. Well, we said pi by 12 was 15, so 5 15s, or 10 15s are 150. 5 15s are 75. So minus 75 is going to be 15 less than 90. So that's going to be this sort of direction here. Okay, so that angle there is minus 5 pi by 12. Right, and that can be W1 as I've drawn it. Okay, the second one was 2 cis pi by 4. Well, we know that pi by 4 is here. Need to make those the same length-ish as possible, and that was W2. Okay, and the third one is 11 pi by 12. Well, we said pi by 12 is 15, well, 12 pi by 12 is pi, so that's 180. So 180 minus 15 is going to be 75, so it's 15 less here, so somewhere like that is going to be our W3. So they are the three roots, and you can see, I'll just draw the angles in. So this argument here was pi by 4, and the third one all the way around there was 11 pi by 12. So if you drew these properly, you would see they're nicely spaced out. So these three angles, these angles in here, should split 3 6. So it should be 120. So what was 120? Well, pi by 3 is 60. So it should be 2 pi by 3 each little angle in here. So 2 pi by 3, 2 pi by 3, 2 pi by 3. The difference between any two arguments of the three roots is 2 pi by 3, and all of these lines have length 2. So if I was to draw these in a circle, this is going to be a terrible circle. It would have a radius of 2 like that. So that would be 2, and so on. 2 up there, minus 2, and so on. You get the idea. So it's not the greatest picture in the world, but that's the idea. So to find the nth root of a complex number, you get it in cis form. You don't forget the k2 pi. You apply De Moivre's theorem using the fractional root to represent using the fractional power to represent the root, and then you go from there and draw a diagram.